Hi everyone. Hope you all are good. So we're going to start with grade 9 maths. So you can find all the lessons on aplusstudents.com. You have to log in there using your email address and password is provided by the administrator. Then you have to select math from the subject tab. Scroll down to grade 9 maths and then click on view all lessons. So there you can find a list of the chapters. Let's just start with the chapter. We're going to start with the chapter statistics, and the lessons we're going to cover today are interpret a scatter plot, match correlation coefficients to scatter plots, quartiles, mean absolute deviation. So let's just start with the first lesson. Interpret a scatter plot. Let's just start with the lesson. Okay, here I'm on grade 9 maths. The chapter name is statistics, and we're going to start with the first lesson, interpret a scatter plot. Okay, just look at this graph. Does this scatter plot show a positive trend, a negative trend, or a no trend? We have to look the trend on the graph. Let's just start with the lesson. Okay, look at the scatter plot. As x increases, y tends to decrease. Draw a line that best fits the data. Notice that line has a negative slope. Got it? That means you have to draw a line that best fits the data. Got it? That means the best fit data means you have to draw a line uh, on the on the opposite sides of the line. You have almost the same number of the points. Got it? So the scatter plots show a negative trend. Negative trend means the slope is decreasing. Got it? A scatter plot shows a positive trend if if y tends to increase as x increases. Got it? Like both y is increasing, x is increasing. That is the positive trend. Got it? A scatter plot shows a negative trend if y tends to decrease as x increases. So y is decreasing as x is increasing. That shows the negative trend. A scatter plot shows no trend if there is no obvious pattern. If there is no pattern in the data, that means the scatter plot has no trend. Got it? So for this one, you can see the values. As y values are increasing, 0 to 6, as x values are increasing, you can see here, as x values are increasing, y values are decreasing. Like when x is 1, y is around 10. When x is 10, y is around 4. So as x values are increasing, y values are decreasing. That means this is the negative trend. Got it? Let's just start with the practice questions. Okay. Does the scatter plot shows a positive trend, a negative trend, or no trend? Okay, just look at the x values. When x is 0, y is 1. When x is 2, y is more than 4. When x is 4, y is more than 6. When x is 6, that means as x values are increasing, y values are also increasing. Got it? That means this is a positive trend. Both the values x is increasing and y is increasing. This is the positive trend in the data. Got it? Okay. Does this scatter plot show the positive trend, a negative trend, or no trend? Got it? So just look at the values. When x is 2, when x is 1, y is around 10. When x is 2, y is around 6. When x is 4, y is around 6. 5. When x is 6, y is 5. When x is 10, y is 4. That means as x values are increasing, y values are decreasing. Got it? That is a negative trend. Got it? As x values are increasing, y are decreasing. That is a negative trend. Got it? Okay. Does this scatter plot shows a positive trend, a negative trend, or no trend? So just look at the values. As y values are increasing, x values are decreasing. Got it? That means the graph shows a negative trend. The graph shows a negative trend. Okay, the next one is this one is negative trend. Okay, let's just move on to the next one. Does the scatter plot shows a positive trend, a negative trend, or no trend? As x values are increasing, y values are also increasing. It shows a positive trend. Okay, the next one is just look at the x values. As x values are increasing, y values are also increasing. Got it? That means that data shows the positive trend. They shows a positive trend. Okay, does the scatter plot shows a positive trend, a negative trend, or no trend? It shows no trend. Got it? So it shows no trend. Okay, the next one is, does the scatter plot show a positive trend, a negative trend, or no trend? It shows a positive trend. Got it? As x values are increasing, y values are tend to increase. So they show a it shows a positive. Okay. It shows no trend, like it shows a mixed values when x sometimes x increasing, so it shows no trend. Oh, positive trend it is. Okay, does this scatter plot show a positive trend, a negative trend, or no trend? It is no trend. Got it? Okay, the next one is, does the scatter plot shows a positive trend, negative trend, or no trend? The scatter plot shows negative trend. Got it? The y values are decreasing as x values are increasing. Got it? So it shows a negative trend. Let's just start with the next lesson. Let's move on to the next one. Okay, the next one is match correlation coefficients to scatter plots. So match each correlation coefficient to the appropriate scatter plot. The latch line in each scatter plot is the least squares regression line. R equals -1 and R equals 0.1. Okay, let's just start with the test question because they all are exactly same. I don't actually get the concept from here. Got it? Let's just see here. Match each correlation coefficient to the appropriate scatter plot. The line in each scatter plot is the least square regression line. They don't have any explanation. Let's just guess the answer. I think it is 2 equals 1 and 1 equals 2. We don't know what does that means. Okay, match each correlation coefficient to the appropriate scatter plot. The line in each scatter plot is the least square regression line. So it is 1 equals 1 and 2 equals 2 because here x values are increasing, y values are also increasing. But no, you are not given any reason why 2 equals 1 and 1 equals 2. It's okay. It is 2 equals 1 and 1 equals 2. Okay, you can leave this topic. Let's just move on to next topic. The next topic is quartiles. Let's just learn what are the quartiles in the data. Okay, let's just start with an example. In the data set below, what are the lower quartile, the median, the upper quartile? So you have to arrange the data from least to greatest. Got it? Like for the given one, the data is already arranged. 15 is the least one and 54 is the greatest one. Got it? So if the data is not arranged, you have to arrange them from least to greatest. Got it? Okay, you have to let's see how many numbers are there in the given data. 1, 2, 3, 4, 5, 6, 7, 7. There are total 7 numbers in the given data. The middle one is 26. Got it? Exact middle one, right? On the right hand side, you have 3 numbers. On the left hand side, you have 3 numbers. That means 26 is the medium. The middle number of the data is the median. Got it? And the number right before the median is the lower quartile, and after the median is the upper quartile. Got it? So the lower quartile is the middle of the lower half. Got it? The lower half is 15, 21, 21. So the middle one is 21 and 21 is the lower quartile. and the upper quartile is the one that is in the middle of the upper half. In the upper half, you have 36, 51, and 54. That means 51 is the upper quartile. Let's just start with the examples. Okay, in the data set given below, what is the lower quartile? The data is already arranged from least to greatest. Let me just count how many numbers are there in the data. They are, mm, where is the pen? Okay, how many numbers are there in the data? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you have the 10 numbers exactly. Got it? Okay, the numbers are, okay, 1, 2. What's wrong with the pen? Okay. Okay, let me just write them down numbers on the whiteboard. Okay, the numbers are 2, 2, 3, 4, 4. Okay. Okay, the numbers are 2, 2, 3, 4, 4 and 6, 6, 6, 7, 9. Got it? They are exactly divided into two halves. You have to calculate the lower quartile. The lower quartile, these are the number at the lower quartile. So the number that is at the lower quartile is 3. The middle and the lower quartile, got it? That would be 3. Got it? So select the correct option and click on the OK button. Okay, the next one is in the data set below, what is the lower quartile? Okay, you have to calculate the lower quartile. So you have 1, 3, and 3. You have to calculate the lower quartile. The lower quartile is 21, 51, and 67 are in the lower quartile and they are in the upper half. Got it? So in the lower one, the middle one is 51. So 51 is the lower quartile. Got it? So it is the 51. The correct option is 51. Okay, in the data set below, what is the upper quartile? Okay, let's just divide data into two halves. They are 1, 2, 3, 4, 5, 6, 7. This one is the median. This one is the upper half. And this one is the lower half. You have to look at the, sorry, the before the median, you have the upper. I am. This is the median. This is the lower and this is the upper. You have to look for the upper. So this 6 is the upper quartile. Got it? So the correct option is okay. So the correct option is 6. Okay, in the data set below, what is the lower quartile, the median, and the upper quartile? Okay, you have to select the lower, upper, and the median. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, this one is the median, exactly middle of the data, that would be 26. The lower quartile, this is the lower one, 21 is the lower quartile, and this is the upper one, 51 is the upper quartile. So it would be 21, 26, and 51. That is option number 1 is the correct option. Got it? Okay, in the dataset below, what is the upper quartile? Okay, so mm, 1, 2, 3, 4. Okay, that is the median, and this is the upper half. So the upper quartile is 51. Got it? So the correct option is 51. Got it? The upper quartile is 51. Okay, in the dataset below, what is the lower quartile? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it would be 1, 2, 3, 4, 5, and it would be 1, 2, 3, 4, 5. Got it? So the lower quartile is 1. Got it? So just select the correct option. The lower quartile is 1. Okay, in the dataset below, what is the lower quartile? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's just divide into two halves the data. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so 4 is the middle one. Got it? That means 4 is the lower quartile. So the correct option is 4. Okay, in the data set below, what is the lower quartile? Okay, let me just count the numbers. They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5. This is the median. 1, 2, 3, 4, 5. 50 is the median. The lower quartile is 35 and the upper quartile is 79. Got it? So they are 35, 50, and 79. Got it? Okay, you can complete the test by yourself later today. Let's move on to the next lesson. And the next lesson is mean absolute deviation. Let's just start with the next lesson, that is mean absolute deviation. So let's just start with the example. Let's see how to calculate the mean absolute deviation. Okay, the first one is in the data set below. What is the mean absolute deviation? You are given with the data set, you have to calculate the mean absolute deviation. Let's see how to calculate the mean absolute deviation. First of all, we have to calculate the median. Got it? So for the median of the data, what we have to do, simply add all the numbers, 36 plus 39 plus 66 plus 54 plus 62, and divide them by 5, because they are 5 in number, 1 2 3 4 5. So you have to sum up all the digits and divide by the, like if they are 5 in number, you have to divide them by 5. So that is the median of the data. Median of the data is 51.4. Got it? Now you have to calculate the mean absolute deviation. So select the mean. The mean is 51.4. Select all the data. Take each number in the data, subtract the mean, and take absolute value. The first one is 36. Like you have to select each values in each data set and subtract them from the mean. 36, you have to do 36 minus 51.4. Here it is. You have to do 6 minus 51.4, the first number, and then subtract from the median. Then second number, 39 minus 51. Also, you have to uh, take their absolute values. Absolute values means in your data no negative values are allowed. Got it? Okay, then the next one is 66 minus 51.4, then 54 minus 51.4, and the last one we have is 62 minus 51.4. Got it? Just calculate their absolute values and add them. It would be 55.6. Got it? You have to calculate the mean absolute deviation. Just divide 55.6 by 5, because the total numbers are 5. That means it is 11.12. Let's just start with the first example. Let's see how to calculate mean deviation, mean absolute deviation. Let's start with the first example. Okay, the data is 15, 21. Let me just write them down on board. 15, 21, 82, 59, and 86. Okay, so first of all, you have to calculate the mean value. Got it? For the mean, you have to add them, 15 plus 21 plus 82 plus 59 plus 86, and divide them by 5, because they are 5 in number, 1 2 3 4 5. Got it? Okay, let me just use the calculator. So 15 plus 21 plus 82 plus 59 plus 86, 263 by 5, and 263 divided by 5 is 52.6. Got it? The mean value is 52.6. Now let's start with the second step. Now you have to take each value from the data and subtract the mean value and calculate this, and absolute value you have to calculate, and then you have to add them. Got it? 15 minus 52.6, 21 minus 52.6 plus 82 minus 52.6 plus 59 minus 52.6 and plus 86 minus 52.6. So let's just subtract each value, and because you have to calculate their absolute values, they all are positive. 15 minus 52.6, that is 37.6. Then 21 minus 52.6, that is 31.6. Then 82 minus 52.6, that is 29.4. Then 59 minus 52.6, that is 6.4. Then 86 minus 52.6, that is 33.4. Just add them all the numbers, 37.6 plus 31.6 plus 29.4 plus 6.4 plus 33.4. Got it? Wait, 15 minus 52.6. Okay, 37.6 plus 31.6 plus 29.4 plus 6.4 plus 33.4. Okay, they all sum 138.4. Divide them by 5. So it is 138.4 divided by 5. That is 27.68. Got it? That means the mean absolute deviation is, I divided them by 5, mean absolute deviation is 27.68. Got it? That is 27.7. Got it? You have to round, you can round off them. It is 27.7. Got it? Okay, let's just move on to the next one. The next one is, the values are 58266, 58266. Let's just calculate the mean. Just add them. 5 plus 8 plus 2 plus 6 plus 6 divided by 5. Got it? Let's just add them. 5 plus 8 plus 2 plus 6 plus 6. So it is 27, and 27 divided by 5 is 5.4. Got it? Okay, now let's just do the second step. You have to subtract each given data from the mean and the absolute value. 8 minus 5.4 plus 2 minus 5.4 plus 6 minus 5.4 and plus 6 minus 5.4. Got it? Let's just subtract each value. It is 5 minus 5.4, that is 0.4. 8 minus 5.4, that is 0.6. 2 minus 5.4, that is 3.4. 6 minus 5.4, that is 0.6 and 0.6. Just add them all. It is 0.4 plus 2.6 plus 3.4 plus 0.6 plus 0.6. That is 7.6, and to calculate mean absolute deviation, divided by the 5. Got it? So 7.6 divided by 5 is 1.52. So the mean absolute deviation is 1.52. So the correct option is $1.52 is the correct option. Got it? Yes, that is 150.52. I haven't selected the, yes, you can round off it to 1.50. Got it? Okay, the next one is, again, you have to calculate the mean absolute deviation. Let me just guess the answer. It is 1.54. Okay, you can complete the test by yourself later today. So we are working on grade 9 maths. Chapter we're working on is statistics, and the lessons we have covered today are interpret a scatter plot, match correlation coefficients to scatter plots, quartiles, and mean absolute deviation. Please make sure before the next session you have to complete all the test questions for the lessons we did today. So if you need more help with the lesson, you can contact any tutor on the site. They are available from Monday to Friday, 5 to 9. Got it? That's all for today. See you in the next session. Bye everyone.